Wow, hey, look you guys, the sun's rising.
The Sun is 4.5 billion years old massive ball of glowing gases. The Sun is simply a star, like the ones we see flashing at night. But because it's closer to us, on Earth it looks much bigger and brighter, and we can even feel heat coming from it. The Sun is the only star in our solar system, which is also the center of it, and the Sun's gravity keeps it together. Our solar system is even named after the Sun. The Latin word for Sun is Sol. Nothing could exist on the Sun, although its energy is vital for the majority of life on Earth. Sun is the largest object in the solar system. Compared to Earth, the Sun is enormous. According to NASA, 109 Earths could be lined up across the face of the Sun, but it turns out that our Sun is only average when compared to other stars. There are bigger stars, such as Red Giant, that are nearly 700 times larger than the Sun, and smaller stars that are only 1/10 the size of our Sun. Earth travels around the Sun in an orbit that is slightly oval-shaped, known as an ellipse. As a result, the planet's distance from the Sun changes throughout the year. The Earth comes closest to the star in early January. Half a year later, in early July, Earth reaches its greatest distance from the star. NASA says that the average distance between Earth and the Sun is around 150 million kilometers. This distance is also known as 1 astronomical unit. That is 400 times the distance between Earth and the Moon. From the pictures, it may seem as if the distance to the Sun is not that great, but it is actually enormous. Another way to understand the distance is to think of driving to the Sun in a car. If you could truly do this while driving at a high speed, say 100 km per hour, it would take you more than 170 years to get there. The Sun is at the heart of the solar system. Everything in our solar system revolves around it at various distances. This is due to the Sun's enormous impact on all of those celestial bodies. Planets, asteroids, and all other objects revolve around the Sun in unique, mostly elliptical patterns called orbits. Orbits are the result of a perfect balance between the forward motion of a body in space, such as a planet, and the pull of gravity on it from another body in space, such as a large planet or star. Almost every object in the solar system has a definite orbit to which it sticks all the time. Also, different planets revolve with different speeds around the Sun. For instance, Earth revolves in an orbit around the Sun in 365 days, 6 hours and 9 minutes with reference to the stars. The 6 hours and 9 minutes add up to about an extra day every 4th year, which is designated a leap year, with the extra day added as February 29th. This question seems to be too simple. Everyone knows the Sun is yellow or orange, since it is visible in the sky and you only have to look to see it, right? But this is not its real color. The Sun appears yellow due to our atmosphere. But when you leave Earth's atmosphere, the Sun appears white rather than any single color. This is due to the way our eyes see color. We are unable to perceive a singular color of the Sun because the amount of sunlight simply causes all the colors to be mashed together in our eyes. When all of the colors of light are blended, the result is white. Thus, to humans the Sun appears yellow on Earth and white in space. We don't see space because it has no surface that can reflect light. We can, however, see planets, stars, or any other matter that has the ability to reflect light. Notice that when you shine a flashlight, it doesn't light up the air between the flashlight and the ground, or wherever it's pointed, unless there is smoke or some other particles hanging in the air. So basically, light is just moving through space and not reflecting off anything. That's why space is dark. A solar eclipse occurs when the Moon moves between the Sun and Earth. When this happens, the Moon stops the Sun's light from reaching Earth. This causes an eclipse of the sun. The moon throws a shadow on Earth during that time. Solar eclipses can be divided into three types. A total solar eclipse happens when the moon passes between the sun and Earth, completely blocking the sun's light from Earth's perspective. A partial solar eclipse happens when the sun, moon, and Earth are not perfectly aligned. The sun appears to have a dark shadow on a small part of its surface. An annular solar eclipse happens when the moon is farthest from Earth. During this time, the moon seems smaller. It doesn't completely block the sun's view. This creates what looks like a ring around the moon. People should never look directly at the sun, even with sunglasses. The human eye is not made to look at an object that bright. The sun is almost 1,000,000 times brighter than a standard light bulb. This is why you may easily hurt your eyes. Looking straight at the sun can cause serious burns that may never heal. The sun emits harmful ultraviolet radiation, which can damage human skin and eyes. In fact, any tan is a sign of damage to our skin. A sunburn may hurt for a while, but damaging our skin over many years can cause many problems, including skin cancer. That is why we should always use sunscreen when spending more than a few minutes in the sun. This applies even for cloudy days. If the sun disappears suddenly, total darkness will be observed on Earth after 8 minutes, the time it takes for its light to reach us. If darkness were the only factor, it would take a while for most life to vanish from Earth. In a few days, the temperature on Earth would drop a few dozen degrees below freezing, and in a matter of weeks, it would be pretty close to absolute zero, which certainly would not be pleasant for you. The atmosphere would also freeze and fall to us, leaving us utterly exposed to the harmful radiation waves that roam through space. Since the sun is the center of gravity in our solar system, its disappearance would result in temporary anarchy among the remaining bodies, and after a few collisions, the system may find a new center. In the sun, hydrogen atoms become compressed and fused together, producing massive amounts of energy in the form of heat. As more hydrogen atoms fuse, more heat is generated, and the sun increases while also becoming lighter. The sun will eventually get so large and hot that it will grill the Earth, making it uninhabitable. But relax, we still have a few billion years before this happens. Once the sun exhausts the hydrogen supplies in its core, it will start burning helium. This starts a swelling and cooling phase that will leave the sun as a massive red giant. The sun will swell to the point when its outer atmosphere will engulf Mercury and Venus. After tens or hundreds of millions of years as a red giant, the sun will enter an unstable phase. It will shed its outer atmosphere, which will form a planetary nebula. The exposed core of the sun will continue to shine at the heart of the expanded nebula, but it will be a white dwarf star, about the size of Earth. It's estimated that the sun has enough fuel to go on for another 5 billion years or so. Thank you for watching. Subscribe to our channel so you don't miss new videos.